Okay, so 4.3 is going to be solving by factoring. I don't know why it's not coming out. What? Oh. I know, what in the world, so weird.
What just happened?
She said, you want to solve by factoring?
I was so confused because that didn't sound like anybody I knew.
Okay, so 4.3, we're gonna solve by factoring, okay? So, a monomial is an expression that is either a number, a variable, or the product of a number and one or more variables. A binomial, such as x plus 4, is the sum of two monomials. A trinomial is x squared plus 11x plus 28. It is the sum of three thank you. You know how to use FOIL, yes. Okay, you guys seemed to like that part yesterday. So if you have x plus 4 times x plus 7, you would get x squared plus 11x plus 28. You can use factoring to write a trinomial as a product of binomials. To factor x squared plus bx plus c, you find the integers m and n. So basically, instead of foiling, we're unfoiling. We're factoring today, okay? We're gonna break it apart. What multiplies to give me the last number, what adds to give me the middle number. And today when we do our factoring, and Monday when we review for your quiz, the factoring on there is only factoring that have leading coefficients of 1, okay? Next lesson, when we do 4, on Wednesday next week, you're gonna factor with leading coefficients that are not 1, like 2, 5, 9, different, okay? There are some rules and special factoring things that we're gonna go over. Listen, on any of the ones that are special factoring concepts, patterns, you have to have them memorized. Period. Okay? Because next year, especially if you go into pre-calc, you will need to have those memorized. And if you go into college algebra, it'll make your life a lot easier too, if you have them memorized. I forgot to go through this. Give me a second, watch this. I have to go through and delete all this stuff. I totally forgot that I didn't do this. But we're going to work on factoring things, yes? Okay. So these are pretty simple to
B
factor.
is not factorable.
Yes.
Let's go.
Why is it not factorable though, Kaden?
Because you can't get,
You can't what?
you can't do it because.
What multiplies to give me negative 12 but adds to give me 3 is the
Nothing.
question. Well, what about, right, because factors of 12 are 1 and 12, right? 4 and 3, and 2 and 6. And none of those will add to get me to where I need them to go, correct?
Yep, that's
Okay.
what I said.
So then, how do you factor the first one? What multiplies to give me 20 adds to give me negative 9? 4 and 5, okay, but what signs have to go with them?
Negative 4, negative 5.
Negative 4 and negative 5, okay? Because if I have negative 4 times negative 5, I get a positive 20. When I have negative 4 and negative 5 added together, I get a negative 9. Beautiful, okay. We're gonna move to the next one. Okay. These are some special factorizations, okay? There's some special patterns in factoring. There's something called the difference of two squares, and there's something called perfect square trinomial. The difference of two squares is when you have a number in the front, like x squared, and you have a number at the end, like 9, that have perfect squares. X squared is a perfect square, 9 is a perfect square. But there has to be a minus in between them, because it's a difference, okay? When you do that, you automatically get a plus b times a minus b. So you don't even have to do math or think it through. You literally just write that down, okay? So x squared minus 4 would factor to x plus 2, x minus 2. Does that make sense? Okay, because the middle will always cancel out because it's a minus sign. And so it will become a minus and a positive, which would cancel stuff out, okay? So, when you have a difference of squares, so when I look at factoring now, I ask myself some questions. I say, first of all, if there's only 2 pieces to it and there's a minus sign, I say, are both perfect squares? If the answer is yes, that means you have a difference of squares and you have to do no work. You just need to take the square root of both of those things and make one with a plus and one with a minus, okay? The other thing that you're going to have is a perfect square trinomial. That's when there's 3 segments to it, okay? When there are 3 segments to it, what I always do before I factor is I look at the beginning and I say, is that a perfect square? I look at the end and I say, is it a perfect square? Ooh, yes, yes, then it's a perfect square trinomial, okay? And if there's both positives in it, then what you do is you take the square root of A and you add it to the square root of B and you square it. That's all you do in parentheses, that's how you factor it. If there's a minus sign, you have the square root of A and you have the square root of B, and in between there's a minus and a square. Now, do you see how it says 2AB there in the middle on both of them? That means that if I take the square root of A and I take the square root of B, it's a perfect square trinomial if I multiply those together and multiply it by 2. Okay? So, x squared plus 6x plus 9, yes, is a perfect square trinomial because the beginning is a perfect square, the end is a perfect square, and if I take 3 times 1, right, because 1 is the leading coefficient there of x and the square root of x, or of 1 is 1. So if I take 3 times 1, I end up getting 3. If I multiply that by 2, do I get 6 in the middle? Yes. So that's how you know if it's a perfect square trinomial. Okay? Down below you have x squared minus 4x plus 4. Well, what's the square root of 4? 2. What's the square root of 1? 1. 2 times 1 is 2. And then times it by 2 again. Do you get a negative 4 in the middle? Yep. So that means that it is a perfect square trinomial. You have to be able to start recognizing these, okay? If you don't recognize them, you're gonna spend more time than you should on it, which means you're not gonna finish your test or quiz. Okay? Because I factor into the, like, when I make your test and quiz, I'm like, hey, that's a perfect square, that should take them 4 seconds. Like, you know what I'm saying? It shouldn't take you long, because you should recognize that and be able to do it. If you're spending all your time factoring it out, then you probably won't finish the problems that are on there. And I'm not always gonna tell you that they are perfect squares, okay? Sometimes I'm just going to have a bunch of them all in a thing together, and it's gonna say factor these. You have to recognize that's the pattern, okay? So, that being said, here's 4 things we can factor. First one, x squared minus 9. How do we factor that? X squared minus 9, how do we factor that?
X plus 3 times x minus.
Yeah, x plus 3 times x minus 3, because it's a difference of 2 squares, okay? X squared, the square root of it is x, square root of 9 is 3, so x plus 3, x minus 3, okay? Second one, q squared minus 100. Is q squared a perfect square? Is 100 a perfect square? Yep, so what would it be?
50.
Not 50, 50 is not the perfect square. What's the perfect square of 100? What times what gives you 100?
20, 10,
10.
10
So it's q minus 10 and q plus 10. Okay. Y squared plus 16y plus 64. Is this a perfect square here? Yes. Is 64 a perfect square? What is the square root of 64? What is 8 times 1? And 8 and then times 2?
16.
So that is a perfect square trinomial. How do you write that out? You write out y plus 8 squared. Y plus 8 squared. Perfect square trinomial. Because if I do this, okay, watch. If you multiply those out together, yes, you get y squared, correct? You get 8y. You get 8y. And you get 64. 8y and 8y is 16, okay? You see how that works? Okay. Now, look at the next one. W squared minus 18w plus 81 is what it says. Does w squared have a perfect square? Okay. Does 81 have a perfect square? what is it? 9. And this has a minus sign, right? So it's W minus 9. Now, here's where you come into a problem. Okay, let me tell you something. Sometimes in the future, let's say that that problem said W to the 4th minus 18W squared plus 81. Okay? Does that have a perfect square? What is it? So it's W squared, yes? And that has a perfect square of 9. What do you have going on there now? W squared minus 9. A perfect square, a difference of squares, right? So you would have to continue to factor that. And since there's 2 of them, you would have W minus 3 squared plus W, not plus, I don't know why I said plus, times W plus 3 squared. Okay, so sometimes you're not done. Do you get what I'm saying? Sometimes you gotta recognize, oh, there was more than one thing there. Because I'm telling you that you will have those. I don't know if they're on this lesson of homework, but they're definitely in the next section of homework, okay? So pay attention to that. If it's like this, you're fine. But if that had a squared in there, that's a difference of squares now, so I gotta keep going, okay? And that's usually where people get tripped up, because they're like, oh no. So, that's what we're looking at. Now, okay, zero product property, okay? The product of 2 expressions is 0, then one or both of the expressions equals 0, right? So, if you multiply 2 things together, that means one, and they get 0, that means one of them was 0 in the first place, okay? If A and B are expressions and A, B equals 0, then that means A equals 0 or B equals 0. So if I have x plus 5 times x plus 2 equals 0, then that means x plus 5 equals 0 or x plus 2 equals 0. That means that x equals negative 5 or x equals negative 2. Okay, so you could have 2 solutions when you're solving for something. So when you are factoring, here's how you tell the difference. When it just wants you to factor, there is no equal sign. When they want you to give them the zeros of something, it will give you an equation and have it set equal to 0. Okay, there will be an equal sign and you have to factor it, then you have to take each piece, set it equal to 0 and tell me what x could equal. Sometimes they're gonna ask you to then plug those back in and check to see which one actually works. Okay, so that takes us to something like this. What are the roots of this equation? Well, this equation is set equal to 0. So my answers aren't like x plus 4 and x plus 12 or whatever. My answers are actual numbers. So I have to factor first, and then I can set them equal to 0 and solve, okay? So, let's factor this. X squared minus 5x minus 36. Is x squared a perfect square? Is 36 a perfect square? What's the perfect square of 36?
6.
Okay, that's higher than that, so it's not a perfect square triangle. So now we ask ourselves, what multiplies to give me 36, but will add to give me negative 5? What multiplies to give me negative 36 and adds to give me negative 5?
Negative 9 and 4.
Meaning, I need to know what the factors of 36 are, yes? 36 is 1 times 36. That doesn't get me to 5 when you add them together. 36 is 2 times 18. That doesn't get me to 36. Or to 5, I
9
mean.
and 4.
You said 9 and 4. Is 9 times 4 36? Which one has to be positive? Which one has to be negative? 9 is negative, 4 is positive. Okay? Negative 9 times 4 gives me negative 36. Negative 9 times x gives me negative 9x. 4x added to that gives me negative 5x. Now, you take each one of these individually and you set them equal to 0. Okay? So you get x equals negative 4, and you get x equals 9. Now, here's where Caden's not gonna like me. I need you to show me all this work. Okay? Because later we're gonna get into more complicated ones, so I need us to get into the process of showing me work this way. Okay? So my answer would have been C, negative 4 and 9. Okay? It didn't ask me to check anything. It didn't ask me to do anything. It just asked me to do that. let's go with this word problem. It says, a town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. The town wants to double the area of the field by adding land as shown. Find the new dimensions of this field. Okay, so this is 400 by 600, or 600 by 400. And they want to add X and X, so they want to add the same amount of land to both sides. How would you figure that out? How could we figure out what the new area is going to be? Okay, by factoring, what do you mean by that? Okay, how would you set that up?
X, minus, or plus, no.
Plus,
X plus 400.
okay, X plus 400, and I'm gonna multiply it by what?
So, X plus 600.
But what is that set equal to?
0.
No,
Oh.
your total.
The total.
Do I have a total so far?
No.
Well, I have a portion of the total. What's the portion of my area total so far? 400 times 600, because I already know that area. What's 400 times 600? What?
Oh,
What's
times.
6, yeah, what's 6 times 4?
For,
So 24,000, right? 24,000,
not two.
okay? Now, how many X's am I multiplying it by?
It's 240,000.
240?
So two zeros.
2 X.
2 X's, right? 2 X's? I'm adding an X here and an X here. So I'm gonna take this, you said 240,000?
Yeah, there's 4 zeros.
Okay, yes, you're right. So I'm gonna take this 240,000, okay? And I'm going to multiply it by 2, because I'm doubling the area, yes? Okay, in this sentence, it told me you're doubling the area. There's also 2 X's, I'm doubling the area, okay? So technically I have X plus 400, okay, times X plus 600 equals 480,000, yes? Okay, now, you were onto something saying it has to be equal to 0. Okay, that's true, which means I need to factor that first, subtract 480,000 to the other side, so it's set equal to 0, and then refactor it. You get what I'm saying? FOIL, subtract, refactor. X times X is X squared, and then I'm gonna get plus 400X and plus 600X, which will give me 1,000X, yes? And then I'm going to get, what's 400 times 600 again? 240,000, right? Equals 480,000, correct? Okay, so then from there, correct, I would subtract 480,000. So you would get X squared plus 1,000 minus 240,000 equals 0. Now I need to factor. And I need to make that factoring bigger. Okay, what multiplies to give me 240,000 but adds to give me 1,000? How did I what? It's not 9, it's a 4. It just looks weird with this marker. Where did the 480,000 go? You subtracted from this side and this side, and 240 minus 480. Yeah, okay. What multiplies to give me negative 240,000 but a positive 1,000? Here's what I would ask. What multiplies to give me 24 and adds to give me 10, right? Or 1, yeah. 10. What multiplies to give me 24 but adds to give me 10? That would be an easier way to look at it. You see what I'm doing? I'm getting rid of all the unnecessary zeros. 4 times 6 is 24, but adds to give me 10. Here's the deal. It has to multiply to give me a negative 24 and a positive 10. That wouldn't work because if 1's negative, it would give me like 12 and 2.
3 and 8.
3 and 8 doesn't work. Caden's right, it's 12 and 2, but look. Here's what I'm saying. If you do, you said 6 and 4, right?
Yeah.
If one of these is negative, I get negative 24, right? But do I get negative 6 plus 4? Do I get 1? or 10, I mean. No. No, it's negative 6 plus 4. Yeah, so that doesn't work because of that. Okay, because these are adding together to give me the middle. These are multiplying together to give me the end. Caden said 12 and 2, right? You said negative 2. So if I multiply those together, I get negative 24. If I add those together, I get, so it's that. Does that make sense? Okay. But multiplies to give me negative, adds to give me positive. So it should technically be negative 12, or positive 1200, right? Because I gotta add those zeros back in to be nice. And it should be negative 200. Now, we are dealing with measurement, correct? Okay, can you have negative measurement? No, so I don't even have to check solutions when I do this, because one's gonna be negative, one's gonna be positive, and you can't have a negative measurement. So when I set this equal to 0, right, I get x equals negative 1200. Can that possibly be what x is? No, because I can't have a negative measurement. When I set this equal to 0, x gives me 200. So they are going to add 200 meters to each side of the field. Okay? We're gonna add 200 meters to each side of the field. Now, we're gonna do one more example, okay? One more example. I'm gonna erase this.
How'd you get 200?
Because you set this equal to 0 and then just move it over. Yeah, you set x minus 200 equal to 0, and then you add 200 to the other side, you get x equals 200. Why is this like off? It's so slow. Okay. Not working. It's too good. Okay. Now, look at this next thing. If the zeros of the function, okay, so find the zeros of the function by writing an intercept form. What a novel idea. Look, when we factor, we are putting it into intercept form. That's why you have to be able to recognize those. Okay? Because let's say this is really hard for us. We don't want to spend time finding the opposite of b over 2a, da 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 da. Why not just put it in intercept form and solve it? You know what I'm saying? If it's easier. Okay. What multiplies to give me negative 12 adds to give me negative 1. 3 and 4. What's positive? What's negative?
4 is negative.
And 3 is, because if I do this, I get 3x, I get negative 4x, that gives me negative x. 3 and negative 4 is negative 12. Over here. Perfect square? Perfect square?
Yes.
So what's perfect square of 36? Is 6 times 2, 12? So what is that going on there? A perfect square trinomial. And that would factor to say x.
Plus 6 squares.
What form is that in?
That's,
Is that intercept form? It could be. It could also be what?
slope?
No?
Oh, no. No.
What'd you say? Vertex. If I leave it written like this, it's in vertex form. If I write it out like this, it's in intercept form. But they asked for intercept, so we're gonna write it like that. But yes, vertex, because it has a square there. Good. Either way works. Coolio? Okay? That's what you're working on in your homework tonight. Those things. All factoring. And on Monday, I will give you more factoring practice. You must be good at factoring from here on out. We've got to get good at factoring. Factoring, 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 factoring.